All right, so chapters 7, 8, and 9, triangles, polar, and conic sections. Number 1 says a kite is at a height of 152 feet. The string connected to the kite is 186 feet long and is connected to a stake in the ground. So imagine the picture here. You got a stake in the ground. You got a kite. The kite isn't going straight ahead or straight above. The kite's at an angle. The wind's blowing it. Here's my kite. It's a nice kite. I had to make it pretty. There's my kite. It talks about it being a height of 152 feet. So how do I show a height? How do I measure height? Up and down. I'm going straight here to the ground. That's 152 feet. If we measure straight to the ground, straight up and down, what else does that tell you about this thing? It's a 90-degree angle right there, and it's going to come back to here. There's my triangle. 90-degree angle. The kite's 152 feet off the ground, and the string is 186 feet, so this is 186. Our ultimate job in this question is to figure out the angle of elevation. So I have two angles that I don't know yet. Do I want to know what's up by the kite or the angle by the stake? It's by the stake, because angle of elevation is from the ground up, and so this right here is going to be the one I want. This is going to be theta. All right, so there were 3 ways that we solved triangles. We did SOHCAHTOA, we did law of sines, and we did law of cosines. All right, the first thing we always try to do is SOHCAHTOA, because technically it's the easiest one. Can we do SOHCAHTOA on this triangle? When do you use SOHCAHTOA? Right triangle. If it's a right triangle, that's SOHCAHTOA. Could you technically do law of sines? Yeah, because I have a power couple. I know 186 and 90, and they're across from each other. But this one, since it's a right triangle, we're going to do SOHCAHTOA. My ultimate job is to find this angle right here. I don't know why it does that. My ultimate job is to find that angle right there. So that's what I'm looking for. All right, so if I'm finding that angle, I need to know 2 sides from that angle. So 152 is a side. Alex, what would you call 152? Is that the adjacent, the opposite, or the hypotenuse to that angle? It's the opposite. It's the O's, so it's one of those 2. Okay, this over here is opposite. What about 186 here, Luis? Is that going to be the adjacent or the hypotenuse? Yep, that's the hypotenuse. Okay, it's the across from the right angle, so he knows that this is the hypotenuse. Which trig function are we using if it's opposite and hypotenuse? So sine of my angle, because I don't know what my angle is equal to the opposite, 152, over the hypotenuse, which is 186. My job is to solve for theta. What do I need to do? What do I need to get rid of to get theta by itself? Sine. How do I get rid of sine? Inverse sine. This is a straight calculator problem. So we're going to pick up our calculator and do that. If we are trying to do the inverse sine, let's look at mode first. What mode do we need to be in? Degrees, because we're talking angles. Do we want to be in polar, obviously? Not polar. So function and degrees is what we want to be in. In my calculator, I'm doing inverse sine. So I'm going second sine, 152 divided by 186. Inverse sine, 152 divided by 186. Hit enter. There's my final answer, 54.8 degrees. Make sure you're actually trying these and not just watching me do it, so you know that you know how to do it. Often kids get to test day and think they know how to do it, and they don't. Questions on the first one? How did what? Hit the delete button. On number 3, it says, I throw a football 50 yards to Chris. So, me, I throw it 50 yards to Chris. And then I turned 60 degrees. So I am still throwing the ball, and I throw the ball. So I am turning 60 degrees, and I am throwing the ball 65 yards to Brennan. I can't spell. The ultimate job here is to figure out how far is Chris from Brennan. That's what I'm looking for, Chris to Brennan. I want to know that. That's X. All right, so we are solving a triangle. The same rules are always going to apply when we solve triangles. We have three ways to solve it. SOHCAHTOA, law of cosines, law of sines. So the first thing, can we do law of sines here? Or I'm sorry, let me restart again. Can we do SOHCAHTOA? No, can't do SOHCAHTOA, not a right triangle. Can I do law of sines? What do you need for law of sines? Power couple. You need two things across from each other. I've got 65, but I don't know that angle. I've got 50, but I don't know that angle. And I've got 60, and I don't know that side. So I can't do power couple here. So the third one is law of cosines. Okay, so we are going to do law of cosines here. What do we know about this triangle? Side angle side, or a corner. We know this corner right here. We're going to use these bits of information. Those things together. I know that side angle side corner there, and we're going to use that information to shoot across to solve for the other side. Okay, Street Fighter. Law of cosines, there's my setup. It doesn't matter what the letters are called, we're just going. A squared, fine, equals the two sides. So 50 squared plus 65 squared minus 2 times 50 times 65 times cosine of my angle. That's just using law of cosines formula, plugging in the sides for the side lengths and the angle for the angle. Doesn't matter. It doesn't matter. So I know that I'm doing law of cosines, and I know that I'm plugging in the sides for where the sides go, and I plug the angle for the angle go. As long as you have identified correctly, you should be good. Luis, did you have a question earlier? No. It's not that type. No, it's side angle side. If you don't have a power couple. If you have a power couple. Right triangle. That's not true. You never have to use SOHCAHTOA. You technically could solve it doing law of sines or law of cosines, but normally if you can do SOHCAHTOA, that's the easiest method.
No matter what, I know that's safe. I can always do law of cosines.
No, not if you have a power couple, you might not be able to do law of cosines. You have to either use law of sines or cosines. We're typing that in, so on my calculator it's 50 squared plus 65 squared minus 2 times 50 times 65 times cosine of 60 degrees. I type that in, I get 3,475. Do you think Brennan and Chris are 3,000 yards apart? You have to do what here? Not inverse. The square root. Because it's a squared or whatever, side squared. So my side distance, A or X or whatever you want to call it, is the square root of 3,475. 58.9. Does that seem a little bit? 58.95. Seems a little bit more reasonable for a distance considering we were 50 and 65. 58 seems like a good number there. Because that's what the formula calls for. Finding the area of the shaded region. So we have two formulas to do area of triangles. Heron's formula and law of cosines for area. Okay, this is a shaded region. So remember when we're doing a shaded region, what we're trying to do, find the area of the big shape, find the area of the little shape, and then subtract out. Right? So what's my big shape here? A big triangle. And then I'm going to find what the little triangle is, and I'm going to subtract them out. That will tell me the shaded region. That's going to be our goal. All right, I'm just going to do the big triangle on this one, and you can do the rest from there. On the big triangle, we're talking about this one on the outside. These are the things I know. 7, 30 degree. Oh, I'm sorry. That's not right. That 30 degrees goes with the inside triangle. So 7, 7, and 5 down below. So we have two sets of formulas. We either can do Heron's. We do Heron's when it's side, 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 or we can do a law of cosines when it's side, angle, side. Which method are we using here? Heron's formula. Since we know all three sides, we're doing Heron's to find the area of the big triangle. Remember, to do Heron's formula, you start off by finding S. S stood for semi-perimeter, which means you're adding the three sides of your triangle up and cutting them in half. It's half of the perimeter, semi-perimeter. So 7 plus 7 is 14, plus 5 is 19. Cut that in half, and you get 9.5. And then we are doing Heron's formula. Heron's formula says you are taking the square root of S times S minus my side length, so 7. And I've got 2 of those, so I'm going to square it. Times S minus my other side length, so minus 5. I'm going to take that and I'm going to type it in. So in my calculator, second square root, 9.5, parentheses 9.5 minus 7, all squared. Parentheses 9.5 minus 5. Close up the parentheses. Hit enter. My final answer is 16.35. Is that the final answer to the whole problem? No, that's the area of the big triangle. That's all I found so far. For the little triangle, it's that 30 degrees 4 triangle. Can you use Heron's formula on that one? No, because you don't know all three sides. So instead, I'm doing the other one. I'll just go ahead and do it because it's easy. I'm using law of cosines, which says you take 1/2 times the sides, so times 4 times 4 times sine of 30. That's how I find the area of the smaller triangle, so I'm just going to type that into my calculator. 1/2 times 4 times 4 times sine of 30. For that one, we get 4. Is 4 my answer? Finally, what do I need to do then? Subtract that 4 out of there. My final answer to the shaded region is 12.35. Questions? Here we go. Number 5, we are graphing. Okay, so this should be easy. We just finished it. Go ahead on your paper and graph that ellipse. X minus 2 squared over 25 plus y plus 1 squared over 9 equals 1. I don't need foci. All I need is for you to graph that thing. Go ahead and do that for me real quick. Here we go. If I'm graphing this thing, Brittany, where's my center going to be? At 2, change the sign. -1, change the sign. So 2, -1. There's our starting spot. How much, Sierra, am I going to go up and down from that center? 3, because she's square rooting the 9 underneath the y and went 1, 2, 3. 1, 2, 3. And then, Jasmine, how much do I go left and right? 5, square root the 25. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is not an ellipse. On the test, I saw that a lot. That's not an ellipse. Those are 4 dots. You need to connect the dots to make it an ellipse. Questions on 5? Number 6 is polar stuff. Converting from rectangular to polar, or converting from polar to rectangular. If I'm going to polar, what 2 letters do I want in the end if I'm going to polar? R and theta. That's what I'm trying to get to. So I've got those 4 formulas on the back wall. Okay, they're on the back of your unit circle. If I'm trying to get R and theta, which set of colors do we want there? Do we want the black formulas or the blue formulas? The black formulas. Pythagorean theorem and tangent. Okay, so the 2 formulas we're using are r squared equals x squared plus y squared, and tangent of theta equals y over x. That's because we're going to polar. This one solves for r and theta like we want. Once we've set it up, it's just a matter of plugging in. So r squared equals 3 squared plus 3 radical 3 squared. We're going to do that. So, Lindsay, what's 3 squared going to get me? 9. 3 radical 3 squared. Remember, we're just squaring both things. So what's 3 squared going to get me? That's 9. And then radical 3 squared is going to get me 3. So that's 9 times 3. So this is 9 plus 27, which is 36. So what's my r going to be here in the end? R is 6. R squared is 36. We square root it and get r is 6. Then we're doing tangent of theta equals y over x. So to find theta, we're doing tangent of theta equals y over x. So Christina, what can I do with that? Cancel the 3. So tangent of theta equals radical 3. What am I going to do with that then? And we're going to find it. We're doing, where's tangent 3? Technically, we're doing inverse tangent on both sides, or better said, I'm going to my unit circle and I'm finding every place that tangent is radical 3. So where on my unit circle is tangent radical 3? 60 degrees, yep, and 240. So my answer is either 60 degrees or 240 degrees. Thumbs up if you want 60 degrees for your final answer. Thumbs down if you want 240. Tyler, why are we picking 60 degrees? They're both positive. X and Y are both positive, just like it is at 60 degrees. So my final answer is 6, 60. Okay, the second one here is very similar but different. On number 8, it says convert from polar to rectangular. If we're going to rectangular, what 2 things are we looking for? X and Y. So the 2 formulas we're using this time are x equals r cosine theta, where this is your r and that's your theta, and then y equals r sine theta. Go ahead and see if you can remember how to do that without me telling you. Here we go. So all you're technically doing is plugging in that -4 and 135. When you see something like cosine of 135, you're going on your unit circle and finding it. That's where I got the negative radical 2 over 2. When I simplify that, Fadila, is my answer going to be positive or negative? It's going to be positive. So x is going to be equal to a positive number because I got 2 negatives. And then what about reducing? What could I do to reduce? Yep, 4 divided by 2 is going to get her 2 with a radical 2 at the end. No negative signs because I had 2 negatives. There's x. My y is going to be very similar. Again, sine of 135 is radical 2 over 2. So in the end here, is my answer going to be positive or negative? Negative. And then 4 divided by 2 again is going to get negative 2 radical 2. That is my y value. Yep. You can write it as an ordered pair, 2 radical 2. I put a weird comma in there. 2 radical 2, comma, negative 2 radical 2. Questions with that one? On the back side, we are doing parabolas here to start. Y squared minus 6y plus 4x plus 1 equals 0. I know it's a parabola. How do I know it's a parabola? Just one thing is being squared. So when I set this up, we're going y squared minus 6y plus blank. Because y is squared, we put it and its partner next to it. Everything else is going to go to the other side. So I'm going to have a negative 4x, a negative 1, and a blank. That's step 1, setting it up. We just did this the other day. We should be good at it still. Nishay, what number is going to go in our blank here? 9, good. Half of b squared. So when she took 6 and cut it in half, she got 3. She squared 3 to get 9, so she put a 9 in both blanks. And she's making it pretty. So parabolas here on the left side, we're going to factor it into that. On the right side, it's going to be something with that involved. we're factoring here. So, Elsa, what's going to go in parentheses with my y here? Good. She took it and cut that x in, or cut that negative 6 in half, cut her b in half to get negative 3. On the left side, it says negative 4x plus 8. So what's going to go in front of the parentheses? She's going to factor that negative 4 out. And so it's like she's dividing negative 4 out of both things. X and with a 2, is it going to be a positive 2 or negative 2? It's negative because one of the thing we're dividing by is negative. There it is. It's in standard form. Go ahead and try to graph that now on your graph. We don't disregard the 8. We divided the 8 by negative 4. We factored the negative 4 out of it. That's not what we're doing. We're factoring out. It's a different factoring technique. And so it's a different setup. Here we go. When I graph this thing, Anya, where's my, or everybody, show me with your fingers, what is the x value going to be of your parabola? Show me with your fingers, what's your x value going to be on your parabola? Positive 2 for my x, positive 3 for my y. Make sure you go x and then y. So 2, 3 is my starting spot. Point, which direction is this parabola going to open? It's y first. So if it's y first, it's either left or right. It's negative, so you know that it's going to open left. Remember what we do next. We take this number and we divide that by 4. That'll tell us our a value. So our a is negative 1. So from my dot, I'm going left 1 because we know it opens left, so that's going to be my focus. When we go right 1, that'll be my directrix. And we know here, since there's a 4 in front of my parentheses, that's the width of my parabola. So from my focus, I'm going up 2 and down 2 to get me a total width of 4, giving me that parabola shape right there. The number in front of the parentheses is 4, so that'll tell me the width of my parabola. I went up 2 and down 2 to get me a total of 4. It's always the number in front of parentheses. Number 11 says write the equation of the ellipse. So as soon as I read that, I know it's going to look like this. We're going to go pretty quick on this one since we just did it the other day. The vertices are at plus or minus 10, so it's a little bit off my graph. I didn't make it big enough, but it's okay. And my foci are at 0 plus or minus 8. From those dots, where do you think the center is going to be? 0, 0. So with my x, I can put plus 0 and plus 0 for my y. Or nothing at all would be great. We've got that set up. Which number can we fill underneath? Can we fill underneath our x right now or underneath our y? Do we know how much we went left and right at all? No, we just know how much we went from there to the top and from there to the bottom. We moved 10 up to the top vertice and down to the bottom. So I take that 10. What do I need to do with it? Square it. So 10 squared is 100. Where does 100 go, underneath my x or my y? Underneath my y, so we throw 100 underneath there. I have no idea how much I went left and right. And again, since they told me foci up here, I know I'm going to use my foci equation. That's our foci equation. That's big number minus small number equals c squared. 100, thumbs up if 100 is your big number. Thumbs down if 100 is your small number. It's your big one because your foci go the same way. I don't know the small number, and it's all equal to c squared. Remember, c is the distance to my foci. So from here to there, it's 8. So c squared is going to be 64. Then I need to answer the question, 100 minus what gets me 64? It's 36. That's my final answer. Two left. Number 13, we're converting from rectangular complex to polar complex. Remember, if we're going polar, what two things do we want again? R and theta again. That hasn't changed. So we're still using the same two formulas to get us R and theta, just like we did a little bit ago. We're using that formula and that formula, r squared and tangent. The only difference between this problem and the problem earlier is we are going to polar complex. So in the end, we are putting it in that z form of r cosine theta plus I sine theta. We're finding out what our r and theta are still. We're just filling it into there. This is my x value, that radical 3. What's my y value? It's a 1. There is a 1 in front of that I. That's my y value. I'm not going to do that one. We just did it a second ago. We shouldn't be too awful at it. Last thing I want you to do here is on number 14, go ahead and graph A, B, C, and D. Remind yourself how to graph those polar values, A, B, C, and D. The first one is 345, so that one's easy. Go to 345, put a dot. That's A. Letter B, negative 3, 210. Here is positive 3, 210 right here. What does the negative radius do to my dot? You run across to the other side. So I'm going to run across on that line to the other side. There's letter B. Letter C, negative 5, negative 135. Here's positive 5, 135. What's the negative radius do? Run across. What's the negative angle do? Flip it. So that is where letter C goes. Letter D is 1, 330. Go to 1, 330, put a dot. There you go. Questions I want you to do.